Hello and welcome to the session where we are going to look at some problems in mechanics. And in mechanics, we are particularly going to look at problems on Newton's laws of motion and some problems on energy. So let's move to the first problem. So here is the statement of the problem. Blocking an angle of 30 degree with the horizontal. The coefficient of static friction between the block and the plane is 0.8. If the frictional force on the block is 10 Newton, the mass of the block is, and the gravitational acceleration is given as 10 meter per second square. So now here the problem is to calculate the mass of the block. Now before we solve the problem, let's first look at the diagram, the free body diagram of this block. So here is the horizontal surface and here is the incline, which makes an angle of 30 degrees. So because of these 30 degrees, now this is the weight of the block. This shows the force due to gravity of this block. Now from the trigonometry, this angle is 60 degrees. Since this angle is 90 degrees, again this angle is 30 degrees. So we can resolve this component in this direction and in this direction, since this angle is 30 degrees. So this component is mg cos 30 and this component is mg sin 30. Now the question, and this is the normal force, okay, and this is the force due to friction. Now the question is we want to find the mass of the block. Okay, so here we can from this diagram we can apply Newton's second law of motion. And if you recall Newton's second law of motion, it states that the rate of change of momentum, or F is equal to ma. Okay, so the acceleration of the body is mass times acceleration is equal to the total applied force. Now here one thing we need to understand is the block is at rest. Okay, so this block is not moving. So if you look at the two components, one is the force due to friction and this component is the force, it's the component due to force due to gravity. Okay, so now since this is at rest, what it implies that, let's look at the next slide. So if we write down Newton's second law of motion, so here we have taken the direction along the incline upwards as a positive and down as a negative. Okay, so this on the left hand side we have some of the forces. So this force due to friction, this is force due to gravity, and now the block is stationary. It means the acceleration is 0. So this is equal to 0. So we get force due to friction as mg sin theta. Now we have been given as the force due to friction is 10 Newton. G is given as 10 meter per second square, and sine theta, theta is the angle of incline, which is 30 degrees. So sine 30 is half. Okay, so this 10 and 10 will go away and we get the mass as 2 kilograms. So this is how we apply Newton's law of second law of motion to get the mass of this block. The next problem, let's look at the next problem. The statement is two particles of masses m1 and m2 have equal kinetic energies. The ratio of their momenta is. So we first need to write down an expression for the kinetic energy of these two particles. So 1/2 mv square is the kinetic, that's how we write down the kinetic energy of the particle. So on the left hand side we have kinetic energy of the particle due to mass m1, and on the right hand side we have kinetic energy of particle which has mass m2. Now these are equal, so now we solve this for this ratio v1 over v2. So if you solve this for v1 over v2, we get this as v1 over v2 is equal to square root m2 over m1. Now we need to find out ratio of their momenta. So if you recall the definition of momentum, it's mass time velocity. So what we do is we multiply and divide this ratio by m1. We multiply it by this ratio m1 over m2. So if you do that, this is essentially momentum of particle having mass m1, and this is momentum of particle having mass m2. And if you do, if you multiply this factor by m1 over m2, and if you bring it into the square root, this factor turns out to be m1 square and over m2 square. So we get this equal to m1 over m2. So this is the ratio of the moment of these particles. Let's look at the next problem. A man weighing 60 kilogram is in the lift moving down with an acceleration of 1.8 meter per second square. The force exerted by the floor on him is. So this is an interesting problem, and we need to go to the free body diagram. So here we have shown the free body diagram. Mg is the weight of that man. Okay. N is the normal force, which is the force exerted by the floor on the man. This is what this. And now the man is in the lift, and the lift is moving down with an acceleration of 1.8 meter per second square. So we have shown this acceleration. Okay. So again, we go back to the Newton's second law of motion. Now here we take upward direction as positive. Okay, so when we write down the Newton's second law of motion, F is equal to sum of the forces is equal to ma. Okay, now since A is pointing downwards, we have minus ma. This is equal to N minus mg. Now we are interested in finding the normal force. So if you rearrange this, N is equal to m into g minus a. If you plug in the values, mass is 60 kilogram. This is 9.8. This is 1.8. So we get this quantity as 8. So 8 into 60, we get the normal force as 480 Newton. So this is the force exerted by the floor on the man, and we have got this using the second law of motion. Let's look at the next problem. Here we have an object with mass of 5 kg, and it has been acted by a force, and there are two components for this force, one along x-axis and one along y-axis. If its initial velocity at t is, we have been given the velocity which has x and y components, the time at which it will just have velocity along y-axis is. So now the problem states that the x component, since it has velocity component just along y-axis, it means that the velocity of the particle along x-axis goes to 0. So what we need to do is we need to find the time by which the velocity will go to 0. And for that, what we need to do is, first thing we need to find it is the acceleration along x-axis. So first, let's write down the component of the force along x-axis is, it's minus 3 Newton. That is the magnitude of this force. So from this force, we can find out what is the acceleration along x-axis, and it's pretty simple. Its acceleration is force over m. So we get this as minus 3 over 5 meter per second square. So this is the acceleration of the body which faces along x-axis. Now to find the time over which the x component of velocity will go to 0, we go back to the kinetic equation. Here Vxf is the final velocity along x-axis, Vxi is the initial velocity, Ax is the acceleration, and t is the time. Now the final velocity is 0, that is what we are looking at. The initial velocity, we have this at t equal to 0, if you recall, the body was moving with 6 meter per second along x-axis. So this is the initial velocity. Minus 3 by 5 is the acceleration, and t is the time. So if we solve this for t, then we get t is equal to 10 seconds. So in this problem, we have used the kinetic equation as well as the second Newton's second law of motion to calculate the time taken by the particle for its x component to get vanished.